In this video, we'll be going through this qualitative analysis planning question that is from a A-level chemistry practical prelim paper. So let's get started. So let's take a look at this YIJC 2021 paper 4 question 2E. So we are told that we have this sample Fa4 which contains 2 cations. Okay, and a student added aqueous ammonia to a sample of Fa4 and observed the formation of a green precipitate that was insoluble in excess of the reagent. All right, so once we know that this is a QA questions, right, I'll strongly recommend going to the end of your paper and to look at the QA notes for the testing of cations and ions as well as gases. Okay, because they provide a lot of hints for you on what they are testing and what is a likely cation or an ion present. Okay, so since for this part we are looking at the testing of cations, we'll go to the notes on cations. All right, so we know that when the student added aqueous ammonia to the sample of Fa4, okay, so we look at aqueous ammonia, we see a green precipitate insoluble in the excess of the reagent. So the one that has a green precipitate insoluble in excess would be iron 2. Okay? Okay. So he concluded that iron 2 was present. So this is what the table, the QA notes shows us as well. So we know that one of the cation present in Fa4 is Fe2+. Okay, and so we are left with another cations to determine. Okay, so next, let's look at this. Next, he placed a spatula of Fa4 in a boiling tube and heated the solid gently. So in other words, this is heating. Okay, and the gas evolved, turned moist red litmus blue. So for your H2A level syllabus, right, once you see a gas evolve which turns moist red litmus blue, very likely the gas is ammonia. Okay, so this gas here is ammonia. So what compound or what does Fa4 contains, okay, which will allow the evolution of ammonia gas upon heating? Well, that would be ammonium ions, right? So very likely ammonium is present in Fa4. Okay, then here they write upon cooling a brown residue was obtained. So this brown residue is basically the oxidation of iron 2 to form iron 3. Okay, and inside your QA notes they also tell us that, right, the green precipitate will turn brown on contact with air. So in other words, the iron 2 present in Fa4 will turn into iron 3, okay, due to oxidation with air. Okay. So from all these notes here, right, very likely we can conclude, or we know that probably there are these 2 cations present. One of it is iron 2 and the other one is ammonium. Okay. So using table 2.2, which is this table, they are asked us to plan and carry out one other test that will enable you to identify the other cation in Fa4. So from here, right, from these 2 paragraphs here, we know that the student has already identified iron 2. So we just need to identify the other cations, which we know from here is very likely to be ammonium ions, right? So how do we test for ammonium? Well, what we will do is we will take a look at ammonium, which is here. So how to test for ammonia? Well, we will add NaOH aqueous, okay, and then heat, and then we will test for ammonia gas, okay, using a moist red litmus paper. So if the moist red litmus paper turns blue, that means ammonia gas is produced and therefore ammonium is present. Okay, so let's write out the test. So the test would be to add aqueous sodium hydroxide to 1 cm³ of Fa4 and warm. Okay. Then observation. Okay, so you are supposed to carry out the test, right? So because we know that ammonium is present, okay, so we will observe effervescence of colorless pungent gas that turn moist red litmus paper blue is produced. So from this, we know that ammonia gas is produced and therefore ammonium is present. So the cation, the other cation present in Fa4 is basically NH4+. Okay, and the ionic equation for this reaction is basically a reaction between NH4+ and OH- from sodium hydroxide to produce NH3 and water. Okay, so that is what to write for here.